Hello guys, welcome to my YouTube channel Shahi Works. In this session, we are gonna learn XGBoost. Okay, so XGBoost, this is also a traditional machine learning model which aims for decision trees in random forests. Okay, now let's begin with this. So, what is this XGBoost? So, instance random subset. So here the tree one result, wait the final result. So next, we'll be moving up the data, its features, building a model. Again, new data, its features, labeling the features as labels and using the model. By using the model, you can able to predict the labels. Okay. So next one, Newton boost, XGBoost, sequential learning and parallel computation. Sequential learning is that is the additive strategy for learning time. Parallel computation is optimizing the end. The evaluation of the decision tree, wagging, random forest, boosted, gradient boosted, and XGBoost. So now let's get started. So XGBoost uses the decision trees as a base learners and combines them sequentially to improve the model's performance. Each new tree is trained to correct the errors made by the previous tree, so it is called as boosting. So it has proven parallel process for training the large data sets quickly. Also, it supports customizations. Okay, now next one, how XGBoost works. So first you have to start with the base learner, calculate the error, train the next tree, repeat the process and combine. So here this is the mathematical behavior. So whereas y1 is the final predict the value of the ith data point, k is the number of the trees with ensemble, f of k into x of I represents the prediction of the kth and ith data point. Okay, so here this is the objective function. Objective theta, here L y of y1 is the loss function and O f of k is the regulation summarizes the over complex tree. So next one, now let's move to what makes the extreme boost extreme? So preventing overlifting. So learning the rate controls each tree's contribution to the final prediction. It also emphasizes lowering learning rate makes model more resilient and conservative, helps to reduce overfitting. It also grows trees level by level and also splits that don't improve the model or tree. This makes trees simpler and faster. Also, it improves the generalization. Now, next one, tree root structure. The tree structure determines the best trees. Okay. Next, for prioritizing the important features. Next, for handling the missing data. XD moves handles the missing data efficiently. Also, sparsity aware of the sphere. It treats the missing value separate category. During tree building, the missing values follows a default direction. Algorithm calculation gains for splitting, consolidation, and missing of separate row. Also, it's used for prediction of the futures and ensures most robust prediction with incomplete info. Next, cache our access in XGBoost. It is the cache memory is faster. The system uses hierarchy memory, frequency as access data as stored. Next, spatial locality data is arranged in cache friendly, reduces reliance on slower main memory. Next, for approximate greedy algorithms, weight quantity awards checking every possible spread. And also, it is cited for the larger data sets. And at last, advantages and disadvantages. When it comes to advantages, it is more scalable and efficient for handling the larger data set. Also, it supports the parallel processing of GPU. It improves the features of important analysis. Disadvantages, extreme was that is the computational intensive, it may be sensitive, prone to overlifting. Also, the feature is important. Overall, that is the interoperability compared to simpler methods. So I hope now you understood.